everyone. In today's lesson, we're going to talk about how to take the derivatives of log functions. Our first log function is actually going to be the ln function. So if I want to take the derivative of ln of u, the derivative is 1 over the inside, 1 over u, times du over dx, which is the derivative of the inside. So let's write that down in words. So the derivative of ln of u is 1 over the inside times the derivative of the inside. So let's do the first basic example. If I'm giving you ln of x, I want to find out what the derivative is. So y dy dx is my derivative, and like we just said, the derivative of ln of x is 1 over what's inside times the derivative of the inside. Well, the derivative of x is just 1, right? This is the inside I'm talking about. When I'm talking about inside, I'm talking about what's in the parentheses. So 1 over the inside times the derivative of the inside. So we can simplify that to be just 1 over x. So dy over dx is equal to 1 over x. And this is the most basic form of an ln function. And they're obviously going to get more complicated, but the most general form is that the derivative of ln of x is 1 over x. So let's look at a more complicated example, like number 2. So if I want to find the derivative, dy over dx, well, first there's a multiple here, so there's a 3, so we're going to leave that there, 3, and then take the derivative of ln of x squared. So the rule is 1 over the inside, so x squared is on the inside, times the derivative of the inside. So the derivative of x squared is 2x. Now, it's important to know that all of these numbers are on top, so that when you simplify it, it'll actually be easier, right? We could put these all over 1. So my simplified answer here is just 3 times 2x is 6x, and x squared is left on the bottom. And I can simplify it by crossing off one of these x's on top with one of them on bottom. So the final answer would be 6 over x. Okay, let's look at example number 3. So in example number 3, I have ln of x, that whole thing squared. So we can't use ln rules just yet because we have a chain rule. So we have to first take this power 2 and use the product rule by bringing it in front. So dy over dx is bring down the 2, keep the inside, and drop the power down by 1. Then we're taking the derivative of the inside. And the inside now is ln of x. So remember, the derivative of ln is 1 over x, or 1 over the inside, times the derivative of the inside, which is 1. So remember, we can just use ln of x and 1 over x to be the derivative. So if we simplify this in nice, simple form, all this is really over 1, so I can multiply the tops. So 2 ln of x all over x. All right, let's look at number 4. So ln of 1 over x. All right, so 1 over x is a bit concerning to me because I know when I'm taking the derivative of the inside, that might be a quotient rule. So what I could do instead is rewrite this as ln of x to the negative 1. And I actually think that might help us a little bit, right? Because I can bring it upstairs, and now this inside is much easier to take the derivative of. So if I want to find the derivative, we say dy dx is 1 over the inside, right? That's the derivative of an ln, 1 over the inside, times the derivative of the inside. So if I want to take the derivative of the inside, I'm going to use the power rule. So take the negative 1, bring it in front, keep the base, and subtract the power by 1. And then we can simplify this a little bit if we wanted to by putting this over 1, multiplying the tops, negative 1 x to the negative 2 over x to the negative 1. And remember, when we're dividing fractions or exponents with the same base, we subtract the exponents. So we're really going to be doing negative 2 minus a negative 1, which if you add those, you get negative 1. So it's negative 1x to the negative 1 power, which can even be written as negative 1 over x to the positive 1. If you want to simplify it even more, right, take this negative exponent, bring it downstairs, and it's positive. That one's a little complicated because of all the negatives, but the idea is still the same. So remember, when I'm taking a derivative of ln, it's 1 over the inside times the derivative of the inside. So why don't you guys pause the video and try number 5 and 6 on your own, and then hit resume when you're ready for the answer. Okay, so for number 5, dy over dx is my derivative, and it's 1 over the inside times the derivative of the inside, which is just 2. And if you write it nicely, it's 2 over 2x minus 3. And remember, you can't cross off those 2's because this is attached by subtraction on the bottom. All right, the last one, number 6, you wanted to model it similarly as you did with number 4. So the first thing I would have written as made this ln of 10x to the negative 1 power. And then when I'm taking the derivative, dy over dx, I would have said 1 over the inside times the derivative of the inside, which was negative 10x to the negative 2. Then I would have put this over 1 and simplified. So negative 10x to the negative 2, because I multiplied these two. Then I'm going to multiply these two, and I'm left with 10x to the negative 1. The 10's will cancel, and I'm left with negative x to the, well, if I subtract these powers, right, I have negative 2 minus a negative 1. That gives me negative 1. And we could leave this as negative 1 over x to the positive power of 1, right? Take this exponent, bring it downstairs, keep this negative on top. All right, so just a conclusion here. When we are taking the derivative of an ln, it's 1 over the inside times the derivative of the inside. All right, let's move on to logs. So similar features, when I'm taking the derivative of a log function, it's 1 over u, 1 over the inside, times ln of the base, times the derivative of the inside. So if we want to write it down in words, it's 1 over the inside times, you even can separate this and say 1 over ln of the base times the derivative of the inside. So that might even be easier. I know I put these two on the bottom, but you could technically break it up into multiplication. So 1 over the inside times 1 over ln of the base times the derivative of the inside. So this one just has 3 steps. So let's do the first one together. So dy over dx is 1 over the inside times 1 over ln of the base. Remember, log base 4, this is the base is a smaller number, times the derivative of the inside, and the derivative of this x squared is nothing other than 2x. And remember to simplify it, put everything over 1, and multiply tops with tops, so 2x, bottoms with bottoms, x squared, ln 4, and simplify any pieces, like this x can cancel with one of those x's, so this is 2 over x times ln of 4. And that would be the final answer there. All right, let's try another one. Example number 2. Dy over dx is the derivative. So 1 over the inside times 1 over ln of 10, ln of the base, times the derivative of the inside. Well, the derivative of e to the x is just e to the x. And if you put this over 1, multiply tops with tops, e to the x, bottoms with bottoms, e to the x, ln of 10. These e to the x's cancel to 1, so 1 over ln of 10 would be your final answer. All right, why don't you try number 3 and then hit resume when you're ready for the answer. All right, so for number 3, the first thing I would have done was rewrite this as log base 5 of x to the 1/2. Then I would have said, okay, dy over dx is 1 over the inside times 1 over ln of the base times the derivative of the inside, which is the derivative here, x to the 1/2. Bring the 1/2 in front, keep the base, and subtract the power down by 1. So we can simplify this a bit by multiplying the tops with the tops. So we have 1, 1, 1, and x to the negative 1/2. So we can make that x to the negative 1/2 on top. And on the bottom, x to the 1/2 ln of 5 times 2. So I'll put the 2 in front. Right? All these are on the bottom here, right? Bottom, bottom, bottom. So technically, this is a negative exponent. So you really could bring it downstairs. So you would have 1 left on top with 2, x to the first power, ln of 5. Now, how did I get that first power? Well, if I bring this x to the 1/2 downstairs, it's really x to the 1/2 times x to the 1/2, where I'm keeping the base, which is x, and adding the powers, which is 1. And if I'm moving this downstairs, I need this placeholder of 1 for the top. All right, let's look at the rest of them. So we've got 4, 5, and 6. So what I'd actually like you to do is take a look at number 4 and give it a shot. My suggestion would be to rewrite this as log base 2 of x to the negative 1. I would never want to do a quotient rule in this scenario. All right, so give number 4 a shot, then hit resume when you're ready for the answer. Okay, so dy over dx is 1 over the inside times 1 over ln of the base times the derivative of the inside, which is this. So negative 1 x to the negative 2. And then you can simplify everything on top or multiply them. And I will put this over 1. So this times this times this goes on the bottom. So 1 x to the negative 1 ln of 2. Now you can either subtract the exponents or move them if they're negative. I'm going to choose to subtract. So we have negative 2 minus a negative 1. Add them, right? So this would be a negative 1 power. So we will have negative 1 x to the negative 1 over ln of 2. And I could technically bring this downstairs. So I have negative 1 over x ln of 2. All right, how about you guys try number 5 and number 6 on your own, and then hit resume when you're ready for the answers. Okay, so 5, dy over dx, is 1 over the inside times 1 over ln of the base times the derivative of the inside. Well, if you notice, the derivative of the inside here is derivative 1 is 0, and x ln 3 looks like it might be a product rule, but it's actually not. X ln 3, well, we know that ln 3 is a number, so think of it as like 4. Whatever the number is, it doesn't matter. 4x. What's the derivative of 4x? Nothing other than ln of 3. So what you'll notice is that the ln's of 3's will actually cancel, and this answer is just going to be 1 over 1 plus x ln 3. This one was tricky. Okay, and then the last one, 6 dy dx, my derivative, is 1 over the inside times 1 over ln of the base times the derivative of the inside, which is the derivative of e is same times the derivative of the power. So remember, you need a couple of steps for this one. And if you notice, these tops with this bottom will cancel. So my final answer on top is just 6x, and my answer on bottom is just ln of 7. And that is my final answer. All right, I know we did a lot today, but feel free to jot down any questions that you might have, and we'll definitely go over them in class tomorrow. All right, have a good night.